Okay. Next, try to solve the next question. Two capacitors of capacitance six picofarad, 600 picofarad and 900 picofarad are connected in series across a 200 volt are connected in a series across 200 volt supply. 200 volt supply. Okay. What you have to do is calculate the effective capacitance of the combination. Calculate the effective capacitance. Calculate the effective capacitance of the combination second one, what you have to do is potential difference across each capacitor and the third one, total charge stored in the system. What do you have to do? You have to calculate effective capacitance of the combination, potential difference across each capacitor, and total charge stored in the system. Now the capacitor is connected in series, not parallel. Okay. Can you help me further? How can we solve this problem? How can we solve this? Okay, two capacitors, we will connect it in a series. Fine. With the supply of 200 volt supply. Then effective capacitance of the combination. One is 600 picofarad. Another one is 900 picofarad. 1 by Cs is equal to 1 by C1 plus 1 by C2, correct? So I can write 1 by 600 into 10 to the power minus 12 plus 1 by 900 into 10 to the power minus 12 is equal to 1 by Cs. So take LCM. What is the answer? What is the LCM? I'll do one thing. 600 into 10 to the power minus 12 into 900 into 10 to the power minus 12. 900 into 10 to the power minus 12 plus 600 into 10 to the power minus 12. Correct na LCM? So this is nothing but 1 by Cs. We want a Cs. So how can we solve Cs? Can I say Cs is equal to 600 into 900? What is the answer? 54. 1, 2, 3, 4 into 10 to the power minus 24 divided by 900 plus 600 is 1500 into 10 to the power minus 12. Correct? Am I right? What is the answer now? What is the answer? Answer is 360 picofarad. Correct? Are you getting the same? 360 picofarad. Second, potential difference across each capacitor. Total it is 200. Across each capacitor you have to find out. How to calculate? Charge was the same. Charge stored across each capacitor is same. That is Q and Q. But here potential is V1, here potential is V2. So how to calculate? We know that. Shall I erase this? Shall I solve it here? Yes, thank you. Q is equal to CV, correct? So Q is equal to C1 V1. Am I right? Q is equal to C1 V1. So V1 is equal to Q by C1. What is the value of Q? Did you calculate Q? No, we don't know what is value of Q. Can we calculate Q? How can we calculate Q? See here, we know CS. That is total capacitance we know. We know the total voltage supply. So I can write total Q is equal to CS into V. Correct? Substitute 360 into 10 to the power minus 12 into how much? What is our supplied potential? 200. So the answer is 72,000 into 10 to the power minus 12 coulomb. Correct? So we know Q now. Can't we calculate V1? Yes. V1 is equal to Q by C1. So Q is 72,000 into 10 to the power minus 12. V divided by C. 600 into 10 to the power minus 12. What is the answer? What is the answer? Is it 120 volt? 6 ones are, 2s are 0. 120 volt, correct? For this one, V2 is equal to Q by C2. So therefore, 72,000 into 10 to the power minus 12 divided by C2, 900. Nine ones are, what is the answer? What is the answer? Nine how much are 72? 8s are 80 volt. So we have calculated now potential difference also. Last one, total charge stored in the system. Total charge is nothing but what? What is the total charge? Already did. Q. Q is nothing but total charge, that is 72,000 into 10 to the power minus 12 coulomb is the total charge stored, or 72 nano coulomb. Either 72,000 pico coulomb or 72 nano coulomb, correct? So for all the three questions, answers are solved. Understood the problems? Very, very important problems these are. Any doubts? Any doubts? Yes. Next. Shall we go for the next problem? Will you try to solve on your own the next problem? Can you try it? Yes, you try it. Okay? We will just change here. Instead of 6, it is 500 picofarad and 900 picofarad. Two capacitors of capacitance 500 picofarad and 900 picofarad are connected in a series across 250 volt supply. Calculate the effective capacitance of the combination and potential difference across each capacitor there, and also total charge stored in the system. Question number 6. Homework. Try to solve. Okay, homework. So there are 2 homeworks. Solve it. Okay, thank you. Welcome back, my dear students. Next question. 3 capacitors of the capacitance 9 picofarad are connected in a series. What is the total capacitance of the combination? What is the potential difference across each capacitor if the combination is connected to a 120 volt supply? Now we have to connect 3 capacitors in series, not in the parallel, now in series. Okay. Each is having 9 picofarad. No changes. Okay. What is the total capacitance of the combination? We have to calculate the total capacitance of the combination. How to calculate? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Correct? This is the formula to calculate the total capacitance. Substitute and calculate. 1 by 9 into 10 to the power minus 12 plus 1 by 9 into 10 to the power minus 12 plus 1 by 9 into 10 to the power minus 12. Try to solve. Try to solve. Is it very difficult? Denominator is same. So 9 into 10 to the power minus 12. 1 plus 1 plus 1. That is 3 by 9 into 10 to the power minus 12. 3 ones are 3 threes are. So 1 by 3 into 10 to the power minus 12 is nothing but 1 by Cs. So Cs is equal to, see, this is not your answer. Your answer is 1 by, your answer is Cs. So Cs is equal to inverse of that. That is 3 into 10 to the power minus 12. Capacitance is nothing but in terms of farad. Correct? Cs is equal to 3 into 10 to the power minus 12 farad. So answer for the first question is over. What is the potential difference across the each capacitor when the combination is connected to the 120 volt supply? So V1, V2, V3, different potential differences are there. Which formula you can, first you have to calculate Q, then calculate V. Correct? Q is equal to Cs into V. That is equal to 3 into 10 to the power minus 12 into V is how much? How much is the V? 120. 36 into 10 to the 360 into 10 to the power minus 12. Correct? Coulomb. As we have calculated in the earlier case, in the same way you have to calculate for this one also. That is Q is equal to C1 V1. Q is then in the same, use that formula, calculate V1, calculate V2 and V3. Okay, further calculation should be done on your own. So V1 is equal to Q by C1. V2 is equal to Q by C2. V3 is equal to Q by C3. What is the answer? You solve it and send it as a homework. Okay? Shall I go for the next problem? Yes, next problem. Question number 8. Calculate the effective capacitance between the points A and B. Shown in figure. Okay, see the diagram. This is the diagram. Okay, 2, 9, 3. Six, 4, 12. So this is the diagram. What you have to do, you have to calculate the effective capacitance of the capacitor between the points A and B for the given diagram. Correct? How to calculate? How can we calculate? Can you help me for calculating this one? How we can calculate? See here, these two are connected in a series. These two are connected in a series. Let me use the color chalk so that you'll be understanding it clearly. See here, these two are in series, hand to hand. See here, correct? Then these two are also in series, correct? But these two are in parallel. These two are in parallel now. These two are in series, so I'll make it 1. These two are in series, I'll take it 1 as. So now this one and this one together, it will be only 2. And then finally the third one for whole. Correct? That is series, series, series. I'll redraw this. See here. First we will consider 9 and 3. 1 by CS is equal to 1 by C1 and 1 by C2. CS for which two we will calculate? 9 and 3. Correct? 9 micro and 3 micro. Okay. 1 by 9 into 10 to the power minus 6 plus 3 into 10 to the power minus 6. Correct? LCM. So the answer is 9 plus 3 12. Three fours are, three nines are. So I can write CS is equal to, or C193 is equal to 9 into 10 to the power minus 6 divided by 4. Correct? Divided by 4. What is the answer? 2.25. 2.25 into 10 to the power minus 6 farad, or 2.25 microfarad. Correct? After we get this answer, I will redraw this. How we got now? This is there. This is now single. Here it is 2, 1. What is the value of this one now? 2.25 microfarad. This is one and the same, 2 microfarad. This is 12 microfarad. This is 4 microfarad. And this one is 6 microfarad. Now we'll go for the next one. That is these two. We'll add these two. What is the answer you get for next two? Same formula, like a series. Which one and all? 12 and 4. Correct? 1 by 12 into 10 to the power minus 6 plus 1 by 4 into 10 to the power minus 6. 48, correct? Minus 12. 4 into 10 to the power minus 6 plus 12 into 10 to the power minus 6. So we'll get it as 12 plus 4. 16 into 10 to the power minus 6 divided by 48 into 10 to the power minus 12. Correct? So I can write C 12, 4 is equal to 3 into 10 to the power minus 6 farad, or 3 microfarad. Am I right? So what is the diagram now? Second diagram. This is same. This is same. This is same. But here only 1 now. This one how much? Earlier 2.25 microfarad we had calculated. Now what is the value of this one? 3 microfarad. This is 2 microfarad. And this one is 6 microfarad. See, I'm drawing the diagram. Each step I'm drawing the diagram so that you will understand. Next, see here. Now these two combined and form single. Earlier these two was there. This is now combined and form single. Next, these two combined form single. Now what I should do? These two we will see. These two are in parallel. Since it is in parallel, now I can say, see here, the connection is, what is the formula for parallel? CP is equal to C1 plus C2, correct? Now in the place of CP, which one and all? 2.25 and 3. Okay, 2.25 into 10 to the power minus 6 plus 3 into 10 to the power minus 6. So we will get 5.25 into 10 to the power minus 6 farad, or 5.25 microfarad. What is the next diagram? What is the next diagram? These two combined now, correct? These two combined. So the diagram is 2, this one and this one now, correct? 2 microfarad. This one is how much? 5.25 microfarad, and this one is 6 microfarad. Correct? Finally, you have to calculate what? All these three. These three are in series. Correct? These three are in series. So we can say 1 by CS, that is 2, 5.25, 6 is equal to 1 by 2 into 10 to the power minus 6 plus 1 by 5.25 into 10 to the power minus 6 plus 1 by 6 into 10 to the power minus 6. Please add this one and get me the answer. Give me the final answer. 2, 5.25, 6. How many farads? That is the total effective capacitance between the points. Next work is yours. You will get one answer for 1 by CS. Then you have to inverse this and give me the answer. I'll give you the rough answer for this. What is the rough answer I will give? That is 1.16 microfarad according to me. 1.16 microfarad or 1.167. It's okay. Microfarad. This you have to solve on your own. Understood? See, this type of problems are important. It is a circuit diagram. Take these two first, calculate, make it 1. Take these two first, calculate, make it 1. Then these two, solution for that. That becomes 1. Then for all the three, you have to calculate as a combination. Directly you cannot add all 2, 9, 3, 6, 4 and 12. Understood how to calculate? Very, 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 very important types of problem this is. Okay? Try to solve. And one homework, you only change these values and solve one problem. I'll not give you the values. You yourself put one values for all these three. All this. Is that okay? Don't. I think I can compare with everyone. Change the values. Instead of 9 and 3, we will keep it as 7 and 4. Here, instead of 6, I will give it as 5. Here, 3. This is the next question, okay? For the next question, this is the diagram. You have to solve on your own. Not your own. See, 2, 7, 4, 5, 4 and 3 microfarad is the next question. You have to solve. So this will be the 9th question, homework. Understood? Okay. Try to solve. Thank you.